Good morning, everyone, depending on where you are, and welcome to the Release 4 Specification webinar, where we'll be overviewing what's gone into developing the Release 4 specifications for Ongo Alliance and give you some additional details about what's happening there. I'm Alan Ewing, the Executive Director of the Alliance. We go ahead to the next slide. So yeah, our agenda today, we have some very highly qualified speakers that have been very involved and leading this effort to bring the Release 4 specifications into existence. So I'll be introducing those folks, but you can see here Gary Boudreau, Jean Fong, Iasan, Masoud Ofat, and Ed Pashan. And so we will bring each of those gentlemen up on camera as we proceed. Go ahead and go to the next slide. Very briefly, just give you a background. I'm sure most of you are aware of this, but the whole purpose of the Alliance is to adopt solutions in the CBRS band utilizing 3GPP technologies. So everything we're doing today is related to the CBRS band. Our job is to really evangelize that in the 3GPP and technologies, LTE, 5G and R, in the shared spectrum, regardless of where it is, but CBRS, of course, being our focus. Will help drive the technology developments, which is part of the specification development process. We'll be doing some advocacy in the background. That's something where we work with marketing, promotion, but also the various regulatory agencies involved here. And then finally, a certification program based on the technical specifications that will be discussed here. Go ahead and go to the next slide. Very briefly, again, our timeline started back in 2010. Many of you know that a lot of things have happened in the interim from the initial NTIA identification of this band for sharing. Notably, full commercial service at the beginning of 2020, the PAL auction, which is key in all of our work, in the middle of 2020, and our evolution to become the Ongo Alliance at the beginning of this year. Next slide. Quick picture of the way we look as an organization. What you see here are the various working groups, really focusing today on the technical working group and the task groups that are part of the technical working group. But we are end-to-end from ecosystem, marketing, test, and cert. But of course, one of our foundational points here is our technical working group. Finally, just to give you a sense, and again, many of you know this already, but just to elaborate, we are nearly 190 member companies. You see what I would refer to as a lot of the usual suspects, but then a really diverse ecosystem of companies that are every niche, cranny part of the ecosystem to bring CBRS, LTE in the CBRS band to fruition. And that's what we've been experiencing. And many of these companies actively participating in the development of these specs. On to the next slide. Anytime you have questions for me, always feel free to drop me a line. But it's my pleasure to welcome Dr. Gary Boudreau of Ericsson up on the stage and ask Gary to start his camera. And Gary, I will turn it over to you, sir.
Thank you, Alan. Next chart, please. So few charts here. Those of you who've attended our previous technical webinars, a lot of this will be review, but I think it's worth going over quickly, either for review or for those of you who haven't seen it, to give you sort of a level set of what we're all about. So as Alan said, the Ongo Alliance it's an industry forum. We were created to champion LTE and NR in the CBRS band in accordance with the FCC Part 96 rules. And for those of you who aren't familiar with FCC Part 96, there's a link here. You can dive down into all the gory details. There's also a very good webinar on the Winform has produced on YouTube. It is a little dated. It was put together in 2015, and a few of the FCC rules have changed since then, but it still gives a very good background for those of you who may not be fully familiar with what CBRS is about. Next chart, please. So diving into a bit more details, what are the differences between Winform and now the Ongo Alliance? So Winform is an official standards development organization. It has multiple committees, and one of those committees is the Spectrum Sharing Committee, which handles the FCC Part 96 rules and works closely with the US government agencies in that regard. It is technology neutral and has many members supporting LTE or 3GPP technologies, but also other technologies, for example, WISPA and or proprietary technologies. It's mandated to develop the requirements and specifications flowing down from Part 96 for the SAS, the CBSDs, ESCs, as well as security interfaces between those components in the network. And most recently, it has put out a release 2, which specifies a number of optional features, including support for multiple technologies in terms of coexistence. In contrast, the Ongo Alliance, as Alan said, our focus is on LT and NR technologies in the CBRS band, and we build upon the requirements defined in Part 96 and the Winform standards. We are focused on developing technical specs to support both LT and NR deployments of private networks, neutral host networks, and multiple service operator networks as examples. There's also a strong focus on LT and NR coexistence in terms of improving the overall performance in a mutually beneficial manner to all the members of the Ongo ecosystem. And as part of that, we also address LT and NR commercialization, business and marketing issues. And as Alan indicated, there's a broad range of members, manufacturers, operators, and industry members in various verticals. In terms of context, the original releases 1 and 2 focused on LT, and initial baseline of NR functionality was standardized in our release 3, and release 4, which we're going to talk about more detail today, has expanded upon that NR functionality. Next chart, please. So in terms of the technical working group itself, our responsibilities include developing, of course, the specifications, best practices, and recommendations and guidelines, and those can be captured in terms of technical reports, for example. And all the relevant documents are published on the Ongo Alliance website with the link indicated here. We also contribute into other fora as appropriate, as we mentioned, Winform, and of course 3GPP. Other bodies include ATIS, a small cell forum, and HTNG, which is a hospitality organization focused on technologies for hospitality. Within the technical working group, the structure is we have 4 active task groups, 1 in coexistence, 1 in network services, radio and home network identifiers, and as indicated in the agenda, we'll be providing more details on each of these relevant to release 4. Next chart, please. So a little bit about interaction with other standards bodies. As I mentioned, 3GPP is the basis of the technical standards that we develop, and our philosophy is not to reinvent the wheel, but to build upon what has been developed in 3GPP for LTE and NR as well. Of course, 3GPP is a global standard. It's developed with hundreds of features and also interacts with many other standards bodies. So we are cognizant of that. And as I said, we work to define specific requirements that are relevant to CBRS that may not be addressed specifically in the 3GPP standards. We also work within the US telecom system framework and relevant FCC rules and various ATIS standards, such as, for example, mobile alerting. And as mentioned previously, also we comply with the Winform requirements and FCC Part 96, which is sort of the base layer upon which CBRS Alliance and Ongo specifications are developed. So the key message here is we're exploiting the strengths of multiple standards bodies to develop a commercial LT and NR solution in the CBRS band. Next chart, please. So what makes CBRS different? As most of you are well aware, LT and NR are designed for essentially mobile network operators principally, to deploy an exclusive use spectrum, typically licensed spectrum, where CBRS is a light, you can think of it as a lightly licensed shared spectrum, and as such, it actually opens up opportunities for new use cases that are not specifically addressed in the legacy 3GPP, such as neutral hosts. That is starting to change in the most recent releases being defined in 3GPP release 17 and moving into release 18, for example. They're starting also to address things such as neutral hosts and non-public networks, and we're monitoring that closely to ensure we have alignment and build upon what is being defined in 3GPP itself. And a few other use cases and areas such as shared home network identifiers, which Ed will talk about in more detail later in this talk, device-based authentication, support for multi-service operator deployments, and many more features. Next chart. So if you're interested in more detail, as I mentioned, you can go to the Ongo Alliance website. There's a link here for all the existing technical specifications that have been approved, as well as previous webinars on release 1, 2, and 3 with the indicated links, and also a webinar on HNI, home network identifiers, if you're interested in getting into more detail on that. And I guess next chart, leave with that, turn it over to Jean to tell us a bit about the radio requirements.
Okay. Hey, thanks, Gary. So my name is Gene Fong. I'm co-chairing the radio task group along with Ivo Angelo, who couldn't be here today. So today I'll do a really quick overview about what we did in the radio task group for release 4. Next slide, please. So, in a nutshell, the topic that we worked on for release 4 was this dynamic spectrum sharing, which I'll abbreviate as DSS, between LTE and NR in the CBRS band. For those of you who don't already know, dynamic sharing or dynamic spectrum sharing is a technique where you use the same carrier and you can deploy both LTE and NR within the same carrier. And it's nice because it enables a migration path from LTE to NR by sharing the single carrier. DSS has been by the way, I hope you guys can hear me. I keep getting these messages that audio is going in and out. But I'll proceed anyways. 3 aspects were studied: channel raster, uplink shift, and sync raster, and I'll go through each one of these in a bit more detail. And in the end, changes were introduced in release 16 3GPP specifications based on this study. Next slide, please. So first, channel raster. So if you take a look at the channel raster between LTE and NR, what we'd like to do to enable DSS is to have a common channel raster that, because we're sharing the carrier, for both rats. And so we want to use a common channel raster. But if you look at how LTE and NR are defined, at least their channel rasters, LTE is defined with a native channel raster of 100 kilohertz, and NR is defined with a channel raster of something like 15 or 30 kilohertz. It's SCS based for channels that, at this 3.5 gigahertz frequency range. And so the least common multiple between these two rasters is 300 kilohertz. But 300 kilohertz, so if I can use 300 kilohertz raster, then I can get alignment between LTE and NR. Unfortunately, it means that 2 of every 3 channels, assuming a LTE 100 kilohertz raster, is therefore unavailable if I have to align to a 300 kilohertz raster. So to solve this, it was envisioned that the center frequency can be shifted by plus or minus 100 kilohertz to snap to this 300 kilohertz common raster. If the channel is not already assigned to a 300 kilohertz raster point. So if you're off by, if you're on a 100, 200, raster, then you shift by 100 kilohertz plus or minus to get to that 300 kilohertz raster. But by doing this, then what you're doing is you're changing your center frequency, but of course your channel remains the same. So if you're changing your center frequency, then the RBs that you're able to operate on then are also in some sense shifted within the channel. And there was concern that by doing this, then the inherent guard band at the edges of the channel might not be enough to meet emissions and so on and so forth. This was discussed extensively in 3GPP, and after all the discussion, it was agreed, and I have a quote here that captures the agreement from a RAN 4 meeting, that the existing specifications, the existing mechanisms for scheduling, and so forth were sufficient to ensure that the UE emission requirements could be met through appropriate configuration and scheduling. Some ideas were like RB blanking and things like that, but there was agreed that no specification changes were needed to address this in particular. Next slide, please. So the second topic that was considered was uplink frequency shift. And the reason that we need an uplink frequency shift is, again, to get this alignment between LTE and NR. And for an OFDM system, you want everything to be orthogonal. And if you don't have that, then you don't have the advantages of OFDM. For the uplink in LTE, the waveform was defined in 3GPP to include a halftone shift, a 7.5 kilohertz uplink frequency shift for the 15 kilohertz SCS, for LTE. And so it was necessary to also include this uplink shift for NR, again, to keep the alignment and the orthogonality with LTE. And in fact, so this was included in the specification. And in fact, if you look very carefully, this was actually the only change in the 3GP specifications to enable DSS is this uplink frequency shift. I also note that the uplink shift, this 7.5 kilohertz shift, is not applicable to 30 kilohertz SCS. It's only applicable to 15 kilohertz SCS NR, since anyways, with 30 kilohertz SCS, you've already lost the orthogonality with LTE 15 kilohertz SCS, so you'll need a guard band between the two. To repeat, there was a 7.5 kilohertz uplink shift that's added to the specification for the 15 kilohertz SCS NR waveform in band N48. Next slide. And the last consideration was for the sync raster. And the reason this was discussed is that it was identified that for this DSS scenario, they're both LTE and NR sharing the same, same spectrum here. There is a potential collision between the NR SSB and the LTE 4-port CRS. These are reference signals sent by LTE and synchronization signals for NR. And the traditional solutions for solving this problem didn't really work very well for band N48. One solution is to configure MBSFN in LTE to give yourself a gap and during the gap you can transmit your NR SSB. But it turned out that we didn't have proper alignment with NR SSB for this LTE TDD, and this would have required some shifting or some changes in RAN 1. And so that wasn't a good solution. Another solution was to introduce a new SSB pattern for band N48 called pattern C. I think no, I'm sorry, to introduce pattern B. The only pattern that exists today is pattern C. And that, potentially could have opened up some slots. Is that it would have increased UE cell search time and power consumption to search for both of these SSP patterns. And also it brings about non-backward compatible changes for band N48 UEs that may already be in development, because band N48 was defined in 3GPP already, quite some time ago, before this these DSS changes were contemplated. So in the end, it was finally agreed that a standards-based solution for mitigation of collision between NRSSB and LTE 4-port CRS was not pursued. So that's my last slide. And again, just to summarize, DSS features have been introduced for band N48 in 3GPP, and with the primary change being this uplink shift in the uplink frequency from 15 kilohertz SCS. And with that, I think the next slide and next presentation is from Yi.
Hi, thank you. My name is Yi Xuan. I am the chair of Coexistence Task Group. Next slide, please. Okay, so today I'm going to talk about the release 4 coexistence specification. For release 4 coexistence specification, we have defined 5 work items that we have completed 2 of the work items. Those completed 2 work items are included in the published release 4.0 coexistence specification. So those 2 items, first is the inter-CXM operation for TDD configuration coordination. So this work item is focusing on how different CXMs can cooperate together so that they can manage the TDD configuration coordination consistently. Note that before release 4, in release 3 and before, we only focus on a single CXM scenario for coexistence of a TDD configuration coordination. But for release 4, we have specified how multiple CXMs should work together. And the other thing we added into release 4 is to support a more flexible NR TDD configuration. Because NR TDD configuration is much more flexible than the LTE TDD configuration. So from the coexistence perspective, we also want to allow the users of the CBRS band to use different NR TDD configurations more flexibly. The other 3 work item in progress is PAL TDD configuration coordination, and then TDD configuration coordination for CBSDs using non-3GPP technology. And then finally, the Winform and the CBRS Alliance coexistence group types and the subgroups handling. So I'm not going to talk about these 3 work items in progress today, but I may talk about it in the future webinar. Okay, next, please. So this slide is a quick overview of how TDD configuration coordination is done by the Coexistence Manager, or CXM. The first thing that the CXM has to do is to create a TDD configuration connected sets. Basically, this TCCS. TCCS is basically a group of CBSDs that they may interfere with each other if they use different TDD configurations. Therefore, the CXM will mandate CBSDs in a same TCCS to use the same TDD configuration. To create a TCCS, the CXM will create so-called edges between CBSDs. So on the graph on the right here, you can see each circle, triangle, or each shape represents a CBSD. And then if there is an edge between two shapes, it means those two CBSD can interfere with each other if they use different TDD configurations. So a TDD configuration connected set basically is a group of CBSDs. They are connected with edges on the graph. So on the figure on the right here, you can see basically there are two TDD configuration connected sets. Some of them include more CBSDs. Some of them includes only, for example, only one CBSD. So all the LT TDD CBSDs and the NR TDD CBSDs that are part of the same TDD configuration connected set, they shall use the same or NR equivalent TDD configuration, with the exception of indoor CBSDs. I will explain what the NR equivalent TDD configuration means later. Next slide, please. So as you can see, to create a TDD configuration connected set is a very important first step. If there are multiple CXMs or coexistence managers, we need to make sure that they create a TDD configuration connected sets consistently. Otherwise, different CXMs will instruct CBSD to use the TDD configuration differently, and then will defeat the purpose of TDD configuration coordination. It is not easy to make sure that different CXMs will create a TDD configuration connected set consistently, because the CXMs, they don't use the same propagation model. Therefore, they cannot determine if two CBSDs will interfere with each other in a same manner. So for this work item, we want to make sure that TDD configuration connected set can be created by different CXMs consistently. That's the first step. And then the next step is all the CXM, they need to choose the same TDD configuration for a TDD configuration connected set, so that all the CBSDs in one TCCS, they will use the same TDD configuration. Next slide, please. So the rules we create to achieve that goal, the goal is to create a common TDD configuration connected set. The rules are listed in the following. First, each TCCS created by a CXM shall have at least one CBSD under the management of the CXM. So that's the rule is created because if a TCCS has no CBSDs managed by the CXM, that CXM really has no say about that TCCS. The second rule is each CXM, they shall exchange the list of CBSD IDs of the CBSDs in each TCCS it creates with the peer CXM. So this is an important step to create a common TDD configuration connected set that I will explain later. The next thing is how to create a common TDD configuration connected set. There are also two sub-rules here. At least one CXM, if at least one CXM puts a pair of CBSDs in the same TCCS, and then also no CXM put the pair of CBSDs in different TCCS, then we put those two CBSDs in the same common TCCS. I think the next slide will have an example to explain these rules better. Next slide, please. So this is an example. So on the left, each circle represents CBSDs. And then there are two CXMs, CXM1 and the CXM2. So the CXM1, it creates a TCCS with ID called the CXM1_TCCS1. It represents as the yellow area, which includes 8 CBSDs. So that's the TCCS created by CXM1. And the CXM2 creates 2 TCCS. One TCCS is covered by 2 CBSD at the top. It's the pink area. And the other TCCS is covered at the pink area at the bottom, near the bottom. It includes also 8 CBSDs. So here in this example, it shows clearly that the 2 CXMs create TCCS differently. So how do we make sure they will use a common TCCS? So by applying the rules that I mentioned before, you will see that the common TCCS can be created on the figure on the right here. There will be 3 different TCCS created. The top has 2 CBSDs. In the middle, there are 6 CBSDs. At the bottom, there are 2 CBSDs. So by applying the rules before, each CXM can perform the operation independently, and then the 2 CXM can create a common TCCS consistently. Next slide, please. So now each CXM has a common TCCS. The next step is to create the same TDD configuration for each TCCS. So if CBSDs in a TCCS have different desired TDD configuration, majority voting will be performed by the CXM based on the fallback TDD configuration. The fallback TDD configuration is either configuration 1 or configuration 2. So the voting result will be either configuration 1 or configuration 2. But the problem is, what about if there's a tie in the voting? So to break the tie, basically each CXM will choose configuration 1 if half of the numbers of the CBSDs in the TCCS is odd number. And if the half of the number of CBSDs in the TCCS is an even number, then the configuration 2 will be chosen. So by doing that, each CXM can independently and consistently choose a TDD configuration for a TCCS. Next, please. So this last slide of mine is to discuss the enhanced support of NR TDD configuration. The NR TDD configuration is a lot more flexible than LTE TDD configuration. The NR TDD configuration, they are specified by 11 parameters. The LTE TDD configuration is specified by only 2 parameters. So currently, we determine if 2 TDD configurations are the same by looking at those parameters. If the parameters, for example, for LTE parameters, if the 2 parameters are the same, we determine those 2 configurations are the same. If 11 NR TDD configuration parameters are the same, and then we determine those 2 NR TDD configurations are the same. However, 2 different NR TDD configurations doesn't mean that they are different in the way that even though that parameters are different, their uplink and downlink symbol can still be 100% aligned. So in the release 4 spec, we provide some pseudocode to explain that 2 NR TDD configurations, even though the parameters are different, they can still be equivalent. So with that, we say that all CBSD in a TDD configuration connected set, if they have the same or equivalent desired TDD configurations, they can use their desired TDD configuration. So this allows more flexibility, more freedom for CBSDs to use different TDD configurations. So this concludes the release 4 coexistence specification summary. I will pass that to Masood.
Yeah, I just wanted to remind folks before Masood starts and invite Masood up. If you do have questions, please enter them into the questions panel. We will hopefully have some time for questions at the conclusion here. So Masood, I'll turn it over to you, sir.
Thank you very much. Can you hear me?
Yes.
Alan, good. Thank you. Wonderful. Okay, good. So good afternoon, everybody. Thanks for your time. My name is Masood Olfat, and I'm the chair of the Network Services Task Group, along with Rajesh Kalia-Perumal from Ruckus CommScope. And so in a very short time, we explain what has been going on in the Network Services Task Group, NSTG, in release 4. Next page, please. So basically, very quick summary of what we had in release 2 and 3. Our objective has been to use the 3GPP network architecture as much as possible, and or other standards, and mostly focus on the area which is specific to share the spectrum. And one of the major work that would be different for us, and we have started dealing with that from the LTE time, was identifying something called a home network ID, the shared home network ID, or SHNI, which is a shared PLMN ID used by all networks using CBRS. Note that, and the value is 3.5-010, identifies a very specific MCC and MNC. Please note that that value is not by law determined and associated with only CBRS Alliance or Ongo Alliance. However, and that can be used by everybody using share the spectrum. However, because management is needed, it's the Ongo Alliance that manages that SHNI. So with that, basically that means we can provide a 10,000 sub IMSI block for each IBN. And given the fact that many users, like private network enterprises might use the same SHNI, a lot of it has a big impact on a lot of aspect of network architecture for 3GPP, given it is LTE or 5GNR, and including the identification of the network, all the IDs, roaming, handoff, definition of neutral host, a lot of aspects, and that has been the main focus of this group. So what we have done in the past, we have been looking at addressing the 5GNR NSA non-standalone network architecture, looking at LTE, looking at extended authentication for LTE, looking at the roaming between LTE network that basically have either both of them are using CBRS PLMN ID shared HNI, or one of them public PLMN ID and another one shared HNI. Looking at, as I said, extended authentication, and the extended authentication is mainly addressing specifically private network. We didn't have that in LTE, but in 5GNR it has been added. Looking at the credential management for credential management capabilities for the extended authentication for LTE. Next page, please. So that has been in the previous releases. In release 4, next page, please, Alan. Good, thank you. So in release 4, we have defined 4 work items and 1 study item and I'm glad to say that we are all of them are completed, and we are kind of starting. We are tackling with release 5 now. The 4 work items that we have worked on, one of them is the concept of extended authentication for 5GNR SA, the standalone case. The rapporteur was Tao Wan from Cable Labs, and it impacts. By the way, I have added the document number here, so people who are interested to see more details. Sorry that within maybe 10 minutes, 15 minutes presentation, there is no way that I can explain all the work done here. So I'm suggesting people to refer to these documents that I'm capturing here. So it's CBRSA TS1003. You can refer to that, available in our public domain. Then we have been looking at NRSA public network support in CBRS, and the rapporteur was Rajesh Kalyapramal from CommScope Ruckus and Zeki Keles from CTS. It has impacted 2 documents, TS1001 and TS1002. Then we talked about the 5GNR SA non-public network, the NPN, how it can be handled in CBRS, and the rapporteurs were Orlet Pearson and Naveen Hatramani from Nokia, impacting both CBRS document 1001 and 2. And finally, we looked at the clarification of UE profiles for LTE and 5GNR, and the rapporteur were myself and Srini Balasubramanian from Celona, and the impacted documents are 1001 and 1002. In addition, we defined a study item that is called UE and network-based solutions for TAC collision, tracking area code collision, and the rapporteur were Srini from Celona and Naveen from Nokia. And for that, a new technical report, TR1004, has been created, which hopefully be published in a public domain. We have finished development of that, and we are moving to our publication. So these are the summary of the works that were included in release 4, and all of those works are completed. Next page, please. Good. So in terms of the extended authentication, so we, for 5GNR NSA, where it's called option 3, where the core network is LTE EPC, there is no change compared to previous releases for external authentication, knowing that for external authentication, the UE uses the NAS communication with the core network, and therefore, as long as the core network is LTE EPC, by NAS I mean non-access stratum, then there is no change between LTE and 5GNR NSA. The only change is the issue of the key derivation during the authentication for ENDC, and for that, basically, the master E node B generates and sends the secondary key G node B to the SG node B. So other than that, no major difference. But for release 4, we're looking at external authentication for 5GNR SA, and for that, people are aware that 5G NPN allows, in 5G we have 3 different ways of authentication. It's 5G AKA, and then one of them is IP AKA, and also another one is IPTLS. So those are being defined already for 5GNR NPN for in release 16. So what we looked at here was the additional authentication IPTLS for 5G SA, and some modification for IPTLS. So you know that per document 33501 in 3GPP, all IP methods are supported, but they have to support the key generation. And so what we did here, we defined the IPTLS development with MS CHAP version 2 for 5G core, and note that this MS CHAP version 2 is executed between the UE and basically the server that supports this mode after the establishment of the TLS tunnel between the UE and AUSF, the authentication server function, which is located in the home network. So basically the 3 operations that are done by this are authentication method selection, the creation and establishment of the TLS tunnel with IPTLS, and finally the execution of MS Chat version 2. So for the detail of these, I suggest you to refer to document TS 1003. Next page, please. So as far as public network is concerned, we identified that there is not a major difference, knowing that the public network is using the public PLMN ID. So the same 5G and RSA architecture may be developed in CBRS band. We also look at the non-roaming 5GC architecture that allows supporting multiple UPFs, especially in the scenario that we are having a private network and some of these UPFs are deployed at the edge. We also looked at the scenario that the access to MNO services with the CBRS network, using CBRS network accessing to MNO service by assuming that the CBRS is working as an untrusted non-3GPP access, and for that, for LTE, it requires to connect to MNO's EPDG, and for 5GNR, it requires to connect to MNO's entry IWF to access MNO services via 5GNR. And again, majority of these are already defined in 5G, 3GPP 5G, so we didn't have to make a lot of changes. Next page, please. The one that we had more effort was this 5GNR non-public network in CBRS. People are aware that 5G NPN is defined in 3GPP in two modes of operation. One is called SNPN, standalone non-public network. Another one is the PNI NPN, which I'm going to talk next page. So we looked at both for CBRS, SNPN, and PNI NPN. Of course, the scenario that we have SHNI for CBRS NPN, and we looked at all possibilities of how the ID assignment can be done. So in the case of SNPN, we know that there is no dependence on the PLMN functionality, and therefore there are different assignment modes. I'm going to talk about that. SNPN suggested the usage of something called need network ID to make the ID of the network unique. So in our case, that SHNI is used, we combine that with the need for something called 5G need. And there are three assignment modes in 3GPP, assignment mode 0 and 2 and 1 and 2. We identified that the use of SHNI is appropriate for assignment mode 0 and 2, which is the coordinated assignment mode. And we determined that self-assignment AM1 is not appropriate. I know that time I need to rush in. So what we did, we defined the structure of the need, 5GC need, for the case of the SHNI, basically using the need is a 44 bits, and we encapsulated the 27 bits CBRS-I broadcast, which is broadcast in SIB1, into that 5GC need, so that we can have backward compatibility with LTE as well. And as I said, we identified that AM1 is not appropriate for CBRS Alliance. Next page, please. For CBRS deployment, we looked at the PNI NPN as well. PNI NPN is that when a private network is being deployed by a public network using CAG or the concept of network slicing, we look at them and we identified that the SHNI is not allowed. So we determined that using SHNI for PNI NPN is not allowed, so we didn't support that. Next page, please. Okay, another area that we were looking at was the clarification of UE profiles for LTE and 5GNR. Note that in release 3 and before, like 2, 3, we defined the concept of UE profiles 1 through 5 for LTE, in addition to a profile called 1A. Here in 5G, we also defined additional profiles which are appropriate and are consistent. Note that when we talk about a 5GNR UE, we are talking about a UE that is using with or without either NEDC or NNDC. These are different approaches of dual connectivity depending on which one is a master. And at least we want to make sure that one of the bands are either B48 or N48. And we developed the profiles 11 to 15 in addition to 11A. And for example, and basically what we did, we also defined mapping between these UE profiles, which are basically defining the capabilities of the UE and the industry-based device types. I'm sure you guys have heard the GSMA defined device types such as DSDS, dual subscription, dual SIM, dual subscription, dual SIM, dual active, and DSDI and DSDA. So we created a mapping between these UE profiles and these industry-based device types. I'm not sure I have time to go through each one of these, what these UE profiles for 5GNR define. I welcome you to look at document TS1001 and TS1002 for the definition of these profiles and their characterization. So just quickly noting that like LTE, the profile that is determined as either 1A or 11A are the case that 5G non-SIM credential-based authentication is used. In LTE also, profile 1A was the one that non-SIM based authentication as a proprietary solution for LTE was considered. Here, this is not proprietary for 5G. It is defined by 3GPP. And also, profile 12 is not defined, and we have reserved it for 5G NR NHN when we define it. Next page, please. Then profile 3, 4, 5, 13, 14, 15 are defined based on the UE supporting multiple subscription, and depending whether it has one active transmit radio or multiple active transmit radio, again corresponding to DSDS and DSDA. And profile 5 is allowing the UE to select the services per subscription. So like voice. So I suggest you to look at the details of this profile. Next page, please. So this is the last page, hopefully. So I'm not going to talk about this. We'll leave it for people to look at it. Next page, please. It's kind of a repetition. Okay, and finally, we were looking at a very important feature, which is called the UE and network-based solution for tag collision. Please note that when we are using SHNI, each IBN block can only use 6 tag values. So we have only 6 values for the tracking area. And given the user of the private network that gets that IBN might have potentially multiple private network, then there is a good chance that these tag areas might be conflicting with each other, and therefore a UE which is not supposed to get into a particular private network might get rejected, and we have a collision of this. So we have been looking at a lot of solutions for this very extensively. We had looked at that. We have looked at it a UE-based solution. We have been looking at a network-based solution, and a document TR1004 has been developed. And the main work is we have created a framework for allowing one of the main solutions that we were pursuing, and that was the geofencing. By allowing the geofencing solution, we allow the UEs to scan and do the tracking area scanning based upon the location of the device without the need to go through GPS search, which impacts the power consumption of the UE. So we have defined a very extensive framework for the geofencing for CBRS network using SHNI. And as I said, the document TR1004 will be out soon, and you can see that in the public. We are moving, this is a technical report. We are moving to make this a technical specification and implementation of the geofence, and hopefully some UE manufacturers can work with us to implement that. So the current work that we are doing is we are looking at the features for release 5, and as Gary mentioned at the beginning, we are very closely watching the development in 3GPP release 17 and 18. Issues such as the roaming for SHNI, for 5GNR, and other aspects are very watched very closely to include in the release 5. So thank you. Sorry, Alan, maybe I went through my time, but waiting for questions.
All right, we'll move along to Ed, thanks, Masood. Go ahead and go off camera.
Thank you very much. Going to quickly skim through this section on identifiers and what's changed in release 4. If we go to the next slide. We'll skip over this. We'll skip over the review because we're trying to do this quickly. So next slide. So the basic problem has already been alluded to is that there is that the PLM and ID system that's used to identify networks isn't really well designed to handle multiple small networks. And so the solution that we've come up with is to have a shared network identifier, the SHNI, used to identify networks operating in the CBRS band, and then defined an additional identifier, the CBRS NID, to identify those individual networks. We use the LTE system for CSG in order to implement this, and that's nice because that does exactly what we need already baked into the 3GPP specs. If you go to the next slide. There's one issue that comes out of this, though, is that LTE has a number of identifiers that need to be globally unique, and the way they ensure that is to include the PLM ID in those numbers. But if we're using a shared PLM ID, that uniqueness is broken. So the solution, if you go to the next slide, is that we takes components of those identifiers and manage them within the Ongo Alliance to make sure that we don't have collisions of those identifiers. And we handle a couple of these different identifiers. Most of these are related to mobility. And so you can request identifiers from the Alliance and we will assign you a unique identifier to ensure there are no collisions when you're using the shared HNI, that shared PLM and ID. Next slide. This also applies to the IMSIs, the identifiers for users that are stored on their SIM cards. Rather than having the Alliance manage all of those IMSIs, what we've instead done is we've broken the IMSI up into 2 components, whereas before there was a 9 or 10-digit IMSIN. We've defined that, split that into an IMSI block number and a UIN number. And with each IMSI block number you can issue 100,000 or so SIMs. These identifiers are actually managed by the US IMSI administrator. That's who you go to for the IBNs. And if you need more than that, you can get multiple IBNs if you need more SIMs than 100,000. So go to the next slide. We also use that IBN to generate tags. Your tracking area codes, you essentially get those for free when you're doing your IMSI block number. You get 6 tracking area codes, but what's come up is that some users need more than 6 tracking area codes. If you go to the next slide, for most deployments, just 1 or 2 tracking area codes is sufficient, but there are certain conditions where you want lots of tracking area codes. And rather than say, just request more IMSI block numbers, what we have done in release 4 is we've added an option to get a managed tracking area code. We use the unused part of that number space for the tracking area codes that the IBN scheme doesn't hit. There's about 5,000 some odd tracking area codes there, and you can request tracking area codes from that managed pool. And we also will note the location at the state level, basically to allow reuse of those tracking area codes if that pool gets over allocated. Next slide. The other big change for release 4, as Masood already mentioned, is the 5G&R SNPNs. You can use the assignment mode 2 and get a unique identifier in combination with that shared PLM and ID. And if you use assignment mode 2, you can use the CBRS NID that we've already defined for LTE, just pad it out with some extra zeros to get the bit lengths to match. And that's all you need for a 5G&R, a standalone non-public network. Next slide. Just a quick summary of all of it put together. If you go to the next slide too, we also have provided mechanisms for reserving these numbers online. The ones that are managed by the CBRS Alliance or the Ongo Alliance can be found at this link on the left. And if you want an IMSI block number from the US IMSI administrator, it's their Form G, and you can request that IMSI block number there. So with that, I think I've reached the end of my time. open the floor to questions. We'll skip my next line, go to the very end.
Very good, thanks, Ed. We're actually up against our time, so I don't think we'll have time for questions formally. We will capture, we did receive a question or two on the questions panel. We will capture those, and those responses will be included as part of the information that's posted onto the Alliance with the recording and the presentation. With that, I would like to say thank you to all of our presenters. Excellent job as always, and also appreciate greatly your attendance for the webinar today. This will be uploaded to the Alliance website and the presentation as well. Then we'll also have the questions that were captured as part of that. So with that, again, my thanks. Enjoy the rest of your Tuesday. And if you do have any questions along the way, please don't hesitate to drop us a line or any questions about the webinar as well. With that, enjoy the rest of your day and take care. Thanks.